Hello, this is checkpoint 2.53, and they want us to describe the hyperboloid. Hyperboloid is like a three-dimensional hyperbola. It turns out that there's two types of these types of hyperboloids. One of them is a hyperboloid of one sheet, and the other is a hyperboloid of two sheets. Anyways, in this particular scenario, we have a hyperboloid of one sheet. And the equation that they give us is x squared divided by 3 squared plus y squared divided by 2 squared plus z squared divided by 5 squared is equal to 1. And they want us to describe it by giving some traces. Okay, actually this is a minus sign. If this was all plus signs, then it would actually be an ellipsoid. And if you have one minus sign, it'll be a hyperboloid of one sheet. And if you have two minus signs, two negative signs, then you have a hyperboloid of two sheets. Okay, describe it by looking at some traces. And the traces are given by knocking off one of the variables. And usually we would set it to 0, but some interesting things can happen too if you set it to some other variable. Let's start off by looking at let's let x equal to 0. And when we let x equal to 0, we have the equation y squared over 2 squared minus z squared over 5 squared is equal to 1. So that is just a two-dimensional hyperbola. And if I were to draw that out on the x on the yz plane, let's see what kind of shape this will be. This will be in the opening along the y-axis. I think when y is equal to 0, there's nothing there. So when z is equal to 0, we have y is equal to 2 plus and minus. So when z is equal to 0, y is equal to plus and minus 2. Let's label this as 2, negative 2. And then our parabola will open sideways. And we can just imagine what the shape of this would be. Let's just draw it out without much detail. I mean, we can draw the asymptotes and find the foci and all that, but let's just say it'll look something like that. Alright, so that's the first part. Let's see. Let's this time let y equal to 0. Then we're going to have an x squared over 3 squared plus 0 minus z squared over 5 squared is equal to 1. This time we would look at a graph that's flat on the xz plane, and that graph would look something like it'll also look like a hyperboloid, but this time I think it'll cross at 3, minus 3 and positive 3 here, and it'll open sideways again. And if we want to look at the slope of the line, the asymptote it's probably going to be, I think it's going to be 5/3 or something like that. Anyways, you just have another hyperbola. Now let's take a look at letting our last variable, let z equal to 0. This time we have something different. You got x squared over 3 squared plus y squared over 2 squared is equal to 1. This time we're looking at the xy plane. And this time we have an ellipse. So going along the x-axis at 3 and negative 3, along the y-axis at 2 and negative 2. We have our ellipse. Okay, some more interesting things we can do. We usually look at traces and see what happens on the coordinate planes, but we can also lift up to see what happens when z is equal to 1 or -1, when z is equal to 2 or -2, etc. So maybe we'll do one more. What happens when z is equal to 5 or -5 or something like that. So let's squeeze that in. What happens when z is equal to 5? I'm choosing 5 because I think it'll be easier to work with. We have x squared over 3 squared plus y squared over 2 squared is equal or minus. This is 5 squared over 5 squared, that's -1 is equal to 1. And I would add something to both sides, and that would be x squared over 3 squared plus y squared over 2 squared is equal to 2. And I would divide by that 2 to make it into a 1. And so I would get x squared over 3 squared times 2 plus y squared over 2 squared times 2 is equal to 1. It's still going to be an ellipse, except the intersections would be a little bit bigger or a little bit wider. So if I were to draw this out, I would probably draw this out something like this. And so what that means is that if whatever the shape is going to look like, and I don't know if you can kind of see the shape already, whatever the shape is going to look like as it goes up higher in the z, you're going to get another ellipse that's a little bit wider. And by the way, if you decide to put a -5 in there, you'll see that you'll get the same thing. So this is what happens when z is equal to positive or -5. All right, let's see if we can try to put it all together in the x, y, z space. And let's start off with this set of hyperbolas. This is flat on the x or on the yz plane. On the yz plane, this crosses at 2, and you'll get some sort of hyperbola shape like that. Now this is a little bit more difficult to draw because it's kind of now tilted, but on the xz plane here at 3, and then I would get another set of hyperbolas. That's going to be a sure. But now if we put it together with this that's flat on the xy plane, it would intersect at those places where I would get that. Only that, but if I go 5 units up, I would get wider. And if I go 5 units down, I would get slightly wider. Hoping that you can start to see this picture, that this picture actually looks like this silo looking shape. All right, so let's see if we can put that silo looking shape together. It's essentially looking like this. And that's your hyperboloid of one sheet. So it has hyperbolas on the sides. If you look at it from one direction or another direction, hyperbolas on the side. And if you make these cuts going up like that, you're going to get ellipses. Okay, that's your visual for the hyperboloid of one sheet. Hope that helps.